So far we have learned how to solve quadratic equations using factoring. From lesson 11 on, we're going to learn different ways of solving these quadratics. We're going to start with, in today's lesson, how to solve quadratic equations using something called completing the square. And that's the number 2 under this list that we did in the very beginning of 4 ways to solve a quadratic. But before we do that, I want us to explore so far what we know and look at some patterns. So I have some equations in factored form on the left, and I want to go ahead and write the factors for it. What you see at the very right are going to be your standard form. In our standard form, we have A, B, and C defined as the coefficients. So whenever I say A, you know exactly what I mean. I'm going to go ahead and distribute and convert all these quadratic equations in factored form into standard form. And as I do them, I'm going to label what my A, my B, and my C values are. And occasionally I'm also going to draw some parallels and describe some patterns that I'm noticing. So initially when I started doing this, the first pattern that I noticed that you may have noticed as well is the C in my standard form is actually the perfect square of the number in my factored form. So let's look at this one. We have a 9 as my C, and we have a 3 as one of the factors in factored form. 3 squared happens to be 9. So that works for x plus 2, that works for x plus 1, and it's kind of hard to see for x plus 1 squared and x plus 2 squared because they're, kind of different the way that they work. But that is the first pattern that I'm seeing. Let me go ahead and work out the x plus 4 squared to see if I can find a different pattern. I encourage you to watch the video and then later take notes as you understand it, or you can also pause the video and convert these equations into standard form with me and check your work. Here we go. 4 squared is 16, so 16 is my perfect square. And when I do x plus 5 squared, I'm noticing that I'm also going to see the same pattern. So basically what I could say is that whatever my C is, if it's a perfect square, one of my factors is going to be the square root of C. But what I want to start looking at right now is also any patterns with B, the B values, the values in the middle. And one of the things that I'm noticing is that they are also connected to your factors and to your perfect square. So right now I'm doing x plus 20 squared, and I'm noticing my C is 400. So the root of that is 20, of course. But I also notice that if I were to multiply 20 times 2, I would get 40. And I wonder if that works for all the other problems as well. What is 5 times 2? That's 10. 4 times 2, that's 8. 3 times 2, that's 6. So another pattern that I've noticed is if you multiply the factor in the factored form times 2, you will actually get the B coefficient in standard form. So I've discovered 2 really huge patterns that are going to help us as we move forward with this new way of solving a quadratic equation. Remember, our factor form is a plus b squared equals a squared plus 2ab plus b squared. And that's basically the pattern that we just discovered, written in a formula. Now, if I can do that from factor form to standard form, I bet I can also work backwards from there. So let's go ahead and give it a try. I have my first problem here. I'm going to take C, which is 36, take the square root of C, which would be a 6. Now I know what you're saying, that's plus or minus 6. But for this purpose, because we see they're all the signals are pluses there, we're just going to use a plus 6. And we're going to write it in factored form. So in factored form, this would be x plus 6 squared. Now you have to raise the entire group to parentheses because that's just the rule when you are doing a binomial square. Now let's look at the second problem here. We have 36, also a perfect square, but we have a negative sign. So if I have a negative sign, some things are going to be a little bit different. Remember when I said the square root of 36 could also be plus or minus 6? Well, what we're going to do in this case is see if the x minus 6 will work. We can't put x plus 6 because that's what worked for the other one, but in here we have a negative. And remember the pattern that we saw last time? That whatever our factor was times 2, that's what our b was going to be. So if I multiply negative 6 times 2, I'm going to get a negative 12. So that's actually going to work, but I'm going to go ahead and use FOIL and multiply it all out just to see if it works, and it does. So now that I know that, I can go ahead and just use this rule to factor all the ones that I need as long as my ends are squares. And as I mentioned before, something else you could do that works with this rule to find the factor is you could look at b, your middle coefficient, which is negative 12, and divide that by x and a 2, and you would get the value, which is in this case negative 6. And you can just plug that in. So that's another way of doing it. You could say that if you divide your middle coefficient, in this case negative 12x, by 2, you could also get the factor. Obviously, we don't need to do that in here because we know 36 is a perfect square and everybody knows that the square root of 36 is 6. But again, I'm just trying to look for patterns that are going to help us learn this new way. So just stick with me here. So I'm going to square out all your b's. Now I'm including the variable here just for simplicity's sake. But you could just grab the number, and that's what I'm going to do. 20 divided by 2 is 10. So I can just simply grab that and factor it out. Now, just because it doesn't divide in evenly doesn't mean that it doesn't work. Keep your fractions as fractions. And as you see here, that will work, negative 3/2, because if I square that, it's going to give me a 9/4. This also works with really large numbers. So I'm going to pause right here and go back to the ones that I worked out this way, starting with x plus 10 squared. And I'm just going to check my answers. Just go ahead and do the FOIL or do the table method, multiply it out, and you'll see that it works for every single one of them. Now the reason this works is because we're following the rule of the square binomials. So it will only work if your ends are squares, perfect squares. It will not work otherwise. So when I look at my very last problem here, I notice right away that that 3 is not a perfect square. So even if I divide that 8 by 2, it's going to give me a 4, and there's no way this is going to work out. I'm going to go ahead and multiply it anyway just so you can see that it doesn't work out. But again, if your ends are not squares, it won't work out. Not the way we know it. And this is why we're going to learn a brand new method called completing a square or completing the square. And this is where you're going to take that squaring of binomials rules and try to use it so that if you find that really easy to do, this is the method that you're probably going to pick when solving a quadratic equation. And this is going to solve your problems whenever you don't have square ends. And again, it's just one way, one method of solving a quadratic equation. One more thing to put in your toolbox. So let's go back to that very last problem that we had. X squared plus 8x plus 3. What could we do with that? We already know that if we divide that 8 by 2 like we did in the last screenshot, we're going to get a 4. So that's actually going to be step 1. I'm going to write out each step for you so that you write down the steps, and then you're going to get some problems to practice them with. So step 1, divide your b by 2. It might be useful to label your coefficients. I label my a, and even though I don't see a 1, we know that that's a 1. I'll label my b, and I'll label my c. b divided by 2, in this case, 8 divided by 2 is a 4. So what we're going to do in step 2 is we're going to take that 4 and square it. I'm going to square it because I'm going to show you that if I were to stop right here and have x plus 4 squared, then what I would actually need, and I'm going to go ahead and solve it all out for you. I would actually need a 16 at that end. And I don't have a 16. I have a 3. So in order for me to be able to use this factored form, I'm going to need that to be a 16. So step 2 is going to be squaring this quotient, squaring the 4. So whatever your answer was for number 1, you're going to square it. That's going to give you a 16 in this particular case. After you square it, you're going to add that number, or the square, to this equation. So when you do that, you're going to automatically imbalance the equation, and to balance the equation out, we're going to need to subtract it. So you're going to do two things that are kind of inverse and cancel each other out. We're going to add the 16. We're going to keep the 3 as it is. And then we're going to subtract the 16. Now let me show you why we're doing this. We want an equivalent expression, right? And so once I have that 16 in there, now I have my factored form. I can use the square of binomials rules. So now I just have x plus 4 squared. I still have my 3, and I have my negative 16. And my last step is going to be to simplify. Now, there's nothing to simplify on the left, but you can combine that positive 3 and that negative 16 to give you a negative 13. And that, friends, is called completing the square. Once you have this, you will have an equivalent expression, but you have it written in a way that you're going to be able to do a lot more things with, and you're going to be able to solve that quadratic a lot faster. Now, I'm not going to go ahead and solve it for you right now, but we're going to do that in future lessons. I'm just showing you how to complete the square. Now, if you wanted proof that these two are equivalent, you can easily go ahead and factor it out, simplify it, expand it, and you'll notice that you'll get the exact same thing on the left as you will from the original equation. So it works every time. These are the steps. Make sure you have them recorded and you know what they mean. Let's go ahead and practice them. I have 5 problems here. I just want you to actually do number 5, number 7, and try number 9. I'll give you the answers in the next video.